Welcome to the School of Architecture. It's our pleasure this evening to be able to welcome Michelle Addington to our first Monday evening lecture of the fall series. We have a new motto here: every night is Monday night. And in keeping with that motto, our next Monday evening lecture will be on Thursday, October 20th. And that will be Case Christians, professor at the ETH and principal of ACAP in Rotterdam. After Case, oddly enough, the following lecture will be by John McMorrow, and that will be on Monday, October 24th. So, strange enough, Monday will be on Monday with John. Michelle's someone we've wanted to get to school for a long time. She's collaborated with some of our faculty members in the past, and is really doing the most interesting work really at the intersection of architecture, the environment, and technologies and materials. For the last 5 years, Michelle has been the Heinz Professor at the Yale School of Architecture. I told Michelle I don't use the S word already, so there's more to that title, but I just say the Heinz Professor, between us. Before that, she taught at Harvard, and before that at Temple. Before entering architecture, Michelle worked at NASA, where she designed components for unmanned spacecraft, and I always knew Michelle was incredibly smart, but now it turns out she really is a rocket scientist, in addition. In addition to her professional architecture degree, Michelle has a BS in mechanical engineering and both MDes and DDes degrees from Harvard. She serves as an advisor on issues of energy and environment for the Department of Energy and the AIA, and in 2009, Architect Magazine named her one of the top 10 architecture faculty in the country. In addition to many articles on energy, environmental systems, lighting, and materials, she has recently co-authored a book entitled Smart Materials and Technologies for the Architecture and Design Professions. Among Michelle's many accomplishments, and I would say really for me some of them, one of the most significant things, that she's really, I think, the first person really since Raymond Banham to make writing about architectural and environmental technologies interesting, smart, and cool. She's a brilliant scholar of technologies whose writing is always first motivated by cultural issues and cultural transformations and effects. And what I was amazed at when I first heard Michelle lecture were two things, one of which was the conceptual power was really a kind of Foucault-like reading of environmental technology. She was tracing the history of the building envelope, and in particular the various paradigm shifts of the building envelope in relation to or in response to whatever the current thinking on disease was at the time, for example. And secondly, the great sympathy that the work had in terms of advanced design ambitions, in particular the way that she was looking at boundary layers as fluid and continuous and often horizontal, as opposed to architecture's typical static reliance on the vertical interface of the wall section. So I think there's very few people who combine the rigors of technical knowledge with an embrace of advanced theory and design, and Michelle is in that very small pantheon. The corollary, I guess for some of you who are doing readings now, would be that I think Michelle's work is to the relationship of environment and architecture and the body in the same way that we say Robin Evans is in relationship to programming architecture and the body. In terms of the work happening here, I think there's a great overlap, and certainly Michelle's work has instigated and enabled a lot of the work that some of you are doing on climate design, for example, and we're happy to have here among our fellow travelers. So please join me in welcoming architecture's rocket scientist, Michelle Addington.
Somewhat difficult and rather troubled relationship with the term sustainability. And when the president of Yale called me to let me know that I had an endowed chair, the endowed chair was called the Heinz Professor of Sustainable Architectural Design, it was okay. I mean, it was more money. But on the other hand, I was just like, I kind of hoped that it was going to be the Heinz Professor of Architecture or the Heinz Professor of Architectural Design. And a a lot of it has been due to this difficult relationship that I've had with the field that really it's very much what I do, it's very much what I'm a part of. Many years ago, when I was not a young faculty member, but a new faculty member at Harvard, it was in the 90s, it was right at the beginning of a whole movement toward green building, and somebody at the medical school had read an article in Time magazine about a particular green architect and decided that whatever we were doing at GSD was completely wrong, that we needed to bring in this guy to tell us what to do. And I was in a very small meeting where I argued, that this was not how one thinks about scholarship, this is not how one makes decisions about an academic discipline, that reading an article in Time, should not be, what we would deal with in terms of moving forward. Within 4 hours, and it was a meeting of about 10 people, within 4 hours I had been put on an environmental hit list to the point where I received numerous death threats over the next few weeks, called an enemy of the planet. And this was only because I was arguing the way that we were going about doing things, not necessarily what we were going to do. And I was giving a lecture at the Kennedy School of Government on actually ways that Harvard could save energy. And it seemed to be kind of modest and a talk that would not upset anyone. But people were so angry that they organized, there was a big protest that was organized around the lecture. So what happened was that they had to close the lecture to the public. I had to have police protection. And 3 days before, Nelson Mandela spoke, and he did not need police protection. And they did not have to close it to the public. And so you can imagine, how I've always had this sort of funny relationship with it. And so last week, or a couple of weeks ago, when I saw in the August Architectural Record, and this is an editorial by George Baird, who's a dear friend of mine, and it was talking about, and I had said, I had heard rumblings, of course, over the year. Many of you have heard about the big lawsuit against LEED. And of course we expect, to see more and more. But, I'd heard lots and lots of rumblings of a bit of backlash. This is the first one that I saw, George's first one that I saw that actually, sort of articulated a little bit about what was going on. And of course he thinks that I would feel really vindicated to see this. And instead I feel quite the opposite. I actually feel a little concerned that this backlash has been developing. It's come to the point where I was at a funeral for a wonderful architect and educator in the spring, and 2 of the 8 eulogies talked about how he hated sustainability. Peter Eisenman, because I think he only does it when I'm there, makes sure that at the end of every lecture, no matter what it's about, that he says that sustainability is a fraud. This is all things that might have resonated with me 15 years ago, except now it worried me. And it worried me because it was an entire system that was ideologically driven. And this is part of its flaws, was the fact that it was a moral imperative, not a scientific imperative, but a moral imperative. And one of the things that happens when something's ideologically driven and it's morals, that it has to be right and wrong. It has to be good and bad. There has to be a right way to do things and other things are wrong. And of course, this is not how discourse moves forward. Discourse doesn't move forward in terms of having a fixed answer. And so, I was worried that, and I'm still actually increasingly worried that we're throwing out a really important concept because of the failure of some very specific and rather idiosyncratic strategies that we've come to associate with sustainability. Now, the other piece of this is last year, the United Nations Intergovernmental Panel on Climate Change asked if I would pull together a session on buildings for the climate talks in Mexico. And I was really surprised when I went down to climate talks that there were as much as we know that buildings are responsible for, the lion's share of energy use, the lion's share of emissions, that nobody in the climate talks were talking about buildings. None of the sessions were about buildings. There were 200 sessions on the side, none dealing with buildings. And when people found out, you know, that I was coming down from architecture, so why would an architect be here? What does architecture have to do with any of this? And the belief is that whatever it is, it's, you know, in terms of the impact of architecture, it's more of a problem of will. It's not a problem of knowledge, according to many people, it's actually a problem of will. And I'm sort of surprised that people still felt that way. And of course, we don't hear that much inside of our profession, that we accuse each other of not, you know, being part of a team. We hear that more from outside the profession, that people really think that we know what we're supposed to do, how come we're not doing it? So one of the things I started doing, and of course part of it was in preparation for this event in Mexico, and part of it was a follow-up to it, but I started reading all of the different documents that were coming out from different governments about what, you know, was the definition of sustainable design in buildings. I'll just sort of run through a couple of them. This is the common carbon metric coming out from the United Nations Environment Program, which is meant to have some kind of level playing field for buildings across the world. There's a statement in here that talks about the fact that energy consumption in both new and existing buildings would be cut by 30 to 50% through readily available technologies, design, equipment, management systems, and indicating that this is already known. In reading this report from the White House, studies by government and industry researchers have found that using currently available technologies can reduce energy consumption by 30 to 50%. National Institute of Standards and Technologies, 30 to 50%, currently available technologies. I've been doing a lot of work in partnership with India, and they have a report as well. Theirs says 25 to 40%, but it turns out that they also use the same source. So when you do a paper trail on these different documents, all of them in it sort of, it's a series of sort of meta sourcing, but they will all source back to a single paper written in the 1990s in which 11 buildings in Southern California were evaluated. This is not that any part of how the fact that this has sort of become embedded and passed on. It's not about, you know, people being disingenuous. It's really about the information that we have so far presumed that when we see something like this, when we see something that has a number attached to it, we take it as fact. You know, we don't take it as perhaps something we might even be careful to cite. We actually take it as a fact. And so we're caught up in this mode whereby the greater policy world really thinks that it's that simple. You know, we really should be just doing these things, not realizing that this is a number that huge amounts of policy has been predicated on. I often talk, and I actually talked to a group of international leaders yesterday, that policy's been a runaway train in this area. Policy's been moving faster, moving forward way faster than the amount of knowledge that we've been able to develop on this. And of course, what you see, part of tying into this is sort of, in many ways, redefining all of this, is that those known technologies show up here. You should be familiar with this chart if you're not. These are part of the McKinsey Charts that most of the world uses as sort of a simplified way of looking at whatever's going on, and they do charts on almost everything. But if you look at this is sort of looking at, what's the biggest bang for our buck in greenhouse gas emissions. By far, it's insulation. By far. Cars, lighting systems, air conditioning, water heating. So, and of course, standby lights for buildings. So you can see that they have already identified, and they believe that almost everything that we could do to impact greenhouse gases, they believe has to do with these very specific things in buildings. It shows up, this comes from the Intergovernmental Panel on Climate Change, where they talk about the difference in developing countries and developed countries. And here you can start to see these sort of standard things show up. Insulation, compact fluorescents. Of course, the compact fluorescents show up all the way through. So, we would just have programs that do this at 30 to 50% would be magically realized. So what I wanted to do, first of all, was talk about the fact there is an incredible array of approaches out there. Of course, LEED is just a piece of it. There's actually a very large array. Where do these different approaches come from? And why may they not be perhaps the appropriate things for us to do now? I only have one boundary layer, which I do like my boundary layers, but there's only one of those. So if we just think about building design, we have seen what we consider to be sustainable design approaches come in three forms. The very quantitative form, the green guidelines with prescriptions and standard codes, our qualitative rating systems, this is where LEED would fall in, and of course, early on, it was signature building, the demonstration project. And of course, one of the things that also happens when I go to so many of these different types of events outside of architecture, and this actually happens in many events with professional architects, is there's a real quick answer that everyone has. Because these things are supposedly known, we need more codes. We need more energy codes. We need more things that require people to do things. But if you look at, we're just talking a 5-year period here. Almost every state turned over an energy code, either adopted one or turned it over and adopted a new one. There is no other kind of code that has been adopted with this kind of rapidity in buildings. It's astonishing how quickly these things have gone into practice. The issue is not codes. Of course, we're all familiar with LEED. When we start thinking about the signature buildings, I've always found it interesting how many of them tended to be skyscrapers. This is, I don't know if you saw the article in the New York Times earlier on the one just all the way on your right. This proposal, out, and I believe this is in Oregon, for this is their idea of a green building is something completely covered in vegetation. There's a whole bunch of those, particularly sort of urban farms coming out there. A couple of years ago, I sat on sort of the more modest version of what is supposed to be signature building, or not necessarily signature, but demonstration, which is the AIA Top 10 Green Buildings. It's a really interesting experience for me. Basically what happens is that you self-nominate. So Chris Foster nominates every building he does as something that should get awarded. And believe it or not, they get awards constantly. A lot of the reason why is that we had a really intense jury on this, and we really only thought 3 buildings deserved it. But lots of discussions back and forth with the AIA. They said the branding was important. We had to come up with 10. So we came up with 10. But what happens with this? These are fairly well documented, and indeed they actually have up to 70, 80 pages worth of energy data that goes along. So this becomes something that gets embedded, whether it's embedded into their database, embedded into other databases. So it's information that becomes readily available to architects, to designers, and to students to copy, to use as a precedent to lift strategies out of these. So many of the strategies are this kind of things like if we put lots of glazing on it, we got daylighting. Bad daylighting, but daylighting. And of course, anything that had the term nature or environment self-nominated, in its title self-nominated, including a startling number of nature centers that were fully conditioned out in the middle of nowhere. But because they were nature centers, they nominated themselves. But a lot of those go into what's been, the Department of Energy maintains as this high performance building database. So it comes from, they pluck out the top 10 buildings, a series of buildings that they have done more detailed studies on, and you go to this database and it will tell you, what this building used, and again, sort of very, very sort of clearly codify and explain and articulate a strategy that you're expected to lift from that. It's a little hard to look at, but it's just really troubling. This is a tool the Department of Energy has been developing to help people learn, to help guide people in designing more sustainable buildings. And if you turn the energy design measure on, a couple of things show up. It wants you to make a one-story building. That means that's going to be more energy efficient, according to this, than a multi-story building. And the reason why it wants to be a one-story building is because they have this extremely high insulation requirement. They want the perimeter to be completely opaque and heavily insulated. So if the perimeter is going to be completely opaque and heavily insulated, the only way to get light is through solar tubes punched in the roof. That demands that it's a one-story building. So basically, it's a Best Buy. You know, it's a big box building. You know, becomes the model of sustainable design if you follow what these different features are. And this has been part of the problem with attaching it to certain types of strategies. That this strategy is the right strategy and that strategy is the right strategy. You end up with this kind of problem. I mean, I like Best Buy, but you know, the thought that that would be a model of sustainable design. I mean, not to shop in it. I mean, you might go online for Best Buy. But we can look now at the same thing going on in cities. And what I've also found very interesting is that there's not as much discussion about sustainable design of buildings anymore, with the exception of LEED. The discussion has really moved up to thinking we have to think about a much more complex format, which is dealing with urban conditions. And we'll find that there's the same sort of three types of approaches when we start looking at cities. That the thought is that we will have an optimized city if we optimize each piece of it. You know, so perhaps each building unit in and of itself is optimized. That we can look at urban form as this sort of isolated, completely contained system in which everything is balanced out. Or we can think about it in a much more complex way as a network which has layers of multiple systems of multiple standards. The City of London, under the Mayor Ken Livingstone, you know, went for the first approach, that if we optimized every piece of this, then we're going to have a much better city. And so part of what he required for the city, or required, and those of you who've worked in London are familiar with many of these things are still in place, even though he's no longer mayor, was it started with every new building had to generate 10% of its energy on site. This is the City of London. 10% of its energy on site was moved up to 20%, and then they started making this requirement if you wanted to renovate a building, you also had to add in a feature in which you generate energy on site. Some people think that sounds really good. The problem is dense city. And if you want to generate energy on site, there's one cheap way of doing it, and it's biomass. You burn biomass. So suddenly they had a huge proliferation of people applying for and trying to put biomass, burning it. The amount of biomass being burned in London went up dramatically. Biomass is something that we tend to associate with the poorest of the poor countries. Granted, we're talking clean much cleaner biomass here, but nevertheless, we start to think about all of those combustion sources being brought into a dense area. So simultaneously, they're also dealing with heat island. You should never have a heat island of this latitude. It shouldn't happen. And this is an indication of the density of the city, the fact that there really are too many, this is not just biomass, too many types of heat generation taking place in the city that can't be relieved. In terms of this idea of things being completely, the ability to look at a utopian version of things, you've probably seen this article some years ago, this particular complex near Syracuse, built the mall that would save America. And there was, you read about this, Destiny USA, world's largest enclosed and integrated structure, protections and climate. You're going to kayak, you're in Syracuse, you're going to kayak here around, you can sort of see part of the enclosure. And the thing is that, Hillary Clinton, much of the U.S. Senate as well as, the state Senate and House, absolutely pushed for this project because, you know, as ridiculous as the description sounds, it was going to make all of its own energy, and it was all going to be renewable energy. But, you know, you start looking at that number, and just sort of putting that number in a little bit of context. Rhode Island doesn't even use that much energy. It might be installed, but it doesn't even use that much. I mean, Rhode Island's not big, but, you know, Providence is not huge. But we're talking about a developer's complex versus an entire state. And of course, you think about the Rust Belt, you think about Syracuse, you think about Rochester, you think about Buffalo. And if there's any place where, any way that you would like to use renewable energy, it would be to replace coal plants that are there, not to justify a completely new type of environment. Just so you can see what it looks like now, not the green part, it's just, this is the part that's in Bill, small part, it says, and you can't really get a shot. So, but this is sort of what they wrote about, the whole thing is about Mother Earth. We laugh at this, but for some reason people don't laugh at this. You know, it's one of these things, there's two things that make me nuts. One is when anyone shows me a termite hill and thinks that's a good example of what a building should be like. And the other one was when they tell me we should look at NASDAR as an example of how we should be designing it. You know, Chris, we've all seen this image before. Probably not so many people have noticed this image under construction. What you see over there, this sort of very large that's the photovoltaic array, part of it to service this. And of course, we're also looking at something being installed in one of the driest locations in the world. You know, we're not even beginning to talk about water issues and so on. And of course, those of you who are familiar with the Emirates know as well sort of the astonishing segregation that takes place there between the wealthy and everyone who serves them. Why would this be a model? You know, why would this be presented to us as a model? And of course, this continues on. This is in Korea. And I also find it fascinating, not the way that we want to sell something that's within the city, is we make sure that we include, you know, a Gucci store within that, again, to indicate that this belongs something to attract the wealthy. You know, all of this really interests me from the standpoint that if you go back to the original definition of sustainable design or sustainable development, which was looking at balancing the needs of human development with the needs of the environment, when Rue Brundtland, the Brundtland Commission, developed that, or pulled together that definition, it was about, when they're talking about development there, they weren't talking about this kind of development, they really were talking about the needs of the greater human community, particularly the needs of developing people, not something that sort of could be isolated, truncated, and evaluated outside of any kind of context. This was an approach to sort of not do either of those two ways, not to look at the city as sort of a collection of optimized units, not to see it as some kind of utopian, isolated walled environment. This was a competition that took place a couple of years ago, and the point of this competition was to take this part of the port of Helsinki and propose for that part, yet show how it related to systems, not just in the city, but systems throughout the entire country. How it could sort of spur development or spur responses in different locations. And this sounds like it's exactly the thing that we should be doing. It's just the hardest thing that we can do. And we really don't have good images, good models, good approaches for doing it. And so if we look at sort of an array, I'm just showing two of the jury responses here. The first one, I won't tell you who did this one, but you can certainly tell who he worked for. More nature, more cities, less suburbs. Someone says, that's a whole new approach for Finland. This included putting towers in certain parts of the city. This was kind of interesting because I was on the jury, and the city planner walked out, says Finns don't like towers, and he walked out. But what I did find really quite interesting, we have lots of conversations about densification. Is densification what we should be doing? And we assume that densification is a good thing. What we found out here is that the density of Helsinki is driven by garbage. How quickly they can remove garbage, and they're really not the density at which they can remove garbage. Something else has to happen for them in order to densify. And then this one here, that really wasn't able to think about it at a small scale, but just sort of as something that we stamped and repeated, endlessly throughout the city. Sort of even challenging. It was sort of so precisely worked out in terms of the fact that they wanted everybody to have sun on, one winter day for 20 minutes, and that angle would get them sun at some certain point in time. But couldn't really see that at a smaller scale, and really actually couldn't see it as something at a larger scale. And so it ended up being something like this. And this, of course, was something done by a dear friend that I have had to avoid for quite some time, as he continues to complain how idiotic we were to turn this down. But you have those as approaches, and of course we think that the idea of these networks of systems, how they overlay, the fact that they all have different domains, we know that's probably how we should be thinking about things, but we don't really have good ways to think in that manner. So if we start thinking about how effective have all of these approaches been, and again, I'm talking about the entire array, I'm not just talking about LEED or one system, we can look at some hard and fast data in a few different locations. The first comes from the commercial building database that the Department of Energy maintains. Many people don't go to this. It's not a friendly database, but there's 4.5 million buildings in this database, sorted by any possible way. You can look at it in terms of whether or not shift workers work there, exactly what kind of functions and take place in it, what its construction type, materials are, and how tall it is. All of that information is in there for 4.5 million buildings. So if you go through this, the first thing you know, buildings reporting energy efficient features used more energy per capita than buildings not reporting these features. It was true for every building type and size, and for every energy efficient feature that was listed. And this was not an anomaly, because in every single survey since they started collecting data, it's been like that. Does it mean that these energy efficient features are wrong? No. I'll explain why. It simply means that we have overprivileged things that are not important. This comes a study that the National Research Council did, auditing. The federal government requires that federal organizations, federal departments are audited. This is the result of their audit, looking at all of the money spent on building energy research. Up until 2000, we've actually spent quite a bit in the last few years, particularly with the stimulus money, but this was looking at it from 1978 to 2000, and they could only find 3 programs in which real energy savings were documented. Advanced refrigerators by far. I don't actually think about that as building design. They are in buildings, as is probably almost all the rest of the electrical equipment, but that was considered a building project. Advanced refrigerators, and those of you of a certain age will know about when this happened. It was really a remarkable difference in performance in the compressor and refrigerator compressors, of almost half the amount of energy today's refrigerators use, and they can be so much bigger. And so they end up using even more energy in the long run. Electronic ballast for lighting probably predates most everybody in here. And then marginally, although still sort of netted an impact, is low and glass. So the only thing we can really think about as being part of architectural design in here is a material that we might select. Not necessarily a material that we see, but a material that we might select. But the other things, none of the other things that they examined, research money, particularly the research money that went into software programs, none of that panned out. So we have things that, we pull these things together, we convince ourselves, we want them to work for us. I happen to be on a campus that claims to have the world's greenest building. And it's Chris here, the AFL-CIO calls it America's greenest building because I worked on it, but it has been much valued since it's been completed. It's Croon Hall, done by Hopkins. And I unfortunately, because I have a project where I'm looking at some new sensing systems, unfortunately I have access to a great deal of information about the building. To show you a quick chart that one of my colleagues, one of my researchers in engineering put together, comparing Croon Hall, the world's greatest building, to Rosencrantz, which is this horrible building done by somebody else I know, so I won't say who it is. But it's a pretty, Rosencrantz is a very standard, straightforward building, academic building, not really incorporating anything that's green. The blue is Croon. So throughout this building period that we looked at from September 2010 to May of this year, consistently Croon used more. Croon uses 80% more than it's projected to use when it was justified. And again, there's some good reasons for that. So we see something like this, and of course, if we step outside of our profession, the assumption is this. It's not that we don't have the knowledge or that we're not applying the knowledge properly, or that we don't have the right solutions or systems. There's still this kind of prevailing belief that it really is a lack of will. So I'm going to sort of share with you what it really is about, and what we're not working on, but what we need to be working on. We tend to ignore this fact that buildings are becoming larger in square meters per capita and per function, square feet per capita per function, really much larger. What we don't really think about when that happens is that we start thinking about the fact that we extend buildings volumetrically. I just bumped out this building by 6 inches all the way around. I've increased materials by the square. I've increased HVAC systems by the cube. I've increased, interesting, I often increase, we think about lighting being planar, I often increase that by the cube as well because we tend to raise our ceilings up, and that does pick up this cubic increase. I can double insulation, I can triple insulation, nothing comes close to what I do simply by making a building larger. One of the easiest ways to give yourself a green building is to slap an atrium in it. If you can put unoccupied space in a building, it calculates out great. Because so many of the things that we have in a building, all of the electrical, the computers, the heat coming off the bodies, if you can just spread them out over a larger area, your energy looks fabulous. Your energy per square foot, per square meter looks amazing. That's the common metric that's used in this country and used internationally. And so buildings that are larger, look so much better according to all of our metrics, even insofar as they are causing the amount of energy to use in total to rise. This is something else that comes from that survey, just looking at high-rise buildings, that high-rise buildings look bad in this, that they use 50% more energy per square foot than low-rise buildings. But they use 50% less energy per capita. And per capita is a much more important way of thinking about what our ultimate impact is. We can't sort of tease, we can't sort of misrepresent what's happening with buildings by making them larger if we start thinking about things per capita. And so even the data we had for Croon, we would still have per square foot data. It's a very under-occupied building, which means rather than being 80% worse, it's probably more like about 200% worse than it should be. Somebody will call me tonight to argue with me about, not argue with me, but complain that I mentioned Croon. For some reason, the vice president of the university hears every lecture I give and calls me about it at some point. If I don't mention Yale, they're upset, and if I mention Yale, they're not positive. I love Yale. I moved to. That building was increased. But when we look at the data worldwide, this is not a U.S. phenomenon. That the space per capita going up at even higher rates. Switzerland, which likes to think it's the best country in terms of sustainable design in the world, this has happened there. The really scary part is going to be China now and India coming up. China, the average living space per person is 64 square meters. It's now 26 square meters. We're seeing that continue to go up. And it's just now starting to see these kinds of increases. These are going to, many people who deal with larger energy numbers worldwide know that our predictions are really low. And a lot of it has to do with this sort of rapid increase in area. The second thing is that our electricity loads have dramatically increased in loads. I'm showing you a picture here of Rudolph Hall at Yale after it was renovated. Rudolph Hall uses 40% more energy after the renovation than it did before. Some of it's attributed to the high efficiency lighting that was installed. It's just so much was installed, and so much has been turned on, and it's a custom high efficiency discharge, high intensity discharge fixture that really you can't use occupancy sensors with it. So they really are all in 24 hours. And I love the fact that it's in the gallery, but almost none of the light is hitting any of the exhibits in the gallery. But that's student work, so that might be But these electricity loads have gone up dramatically. So much more electrical equipment, particularly digital equipment. The electric lighting, so we know that we light according to space. So obviously, as we're increasing space, that matters. But our lighting standards have continued to increase even as people become more conscious about energy use. We're still requiring more lighting. So it's not just more area being lit, we're requiring more foot candles or more lumens in that area. And then if we have time, I want to explain what I mean by this. By high exergy, we are swapping out what we call low quality energy for high quality energy, which demands electricity. So the way to think about anything that uses electricity is that it uses 3 times the primary energy of things that don't. So as soon as you sort of choose that you're going to use electricity, high exergy, you end up consuming a great deal more energy on a straightforward energy exchange basis. This is a great image. I may not have shared this with you, but I also do a history of lighting. And the history of lighting is this astonishing history. The history of why we have the HVAC systems that we do is just bizarre, but not as bizarre as why we have fluorescent lighting. But part of that's a whole other lecture that I'm dying to go into, but I don't know to do that right now. But we were convinced that we could not have sort of discrete lighting. We could not have lighting. I'm not even talking task lighting. We could not have this deal with any kind of variability in space. So if you look at how lighting design takes place, is that you have a required limit level, and then it's all sorted out into evenly distributed luminaires, whether fluorescent or whatever kind they might be. Now, just to make up for anything I said about Yale, pick on Harvard. This is Globe Library at Harvard, and this is after energy efficient retrofit, where they came in and they put in these high efficiency fluorescents, but what they had before is only every other one was lit before. They removed every other one. Instead, they came in and they lamped it, and so it's relentless. There's parts of it on the left that are next to the floor-to-ceiling glazing, parts on the right that are completely in the bowels of the building, parts of this that the body can't possibly get into. It's just the same. This is the way lighting is designed. And if you go and look at where lighting standards come from, they come from industry. Industry has a real stake in having us continue to specify large amounts of lighting. This has really amped up, really increased a lot of our electrical energy use. I love this chart. Sean Bell loves this chart. Sorry that he's not here. But this is one that consumed, and that's how much is wasted and how much is actually doing its job. So you come down to transportation, and what you can see is that I improve the conversion, of an automobile engine. I made a big dent in this. Industry has done a tremendous job of sort of like really cutting down its energy use. A lot of it is because it's direct dollars in their pocket. You would think the same thing would be true for buildings. If you look up here at residential and commercial, you would say, well, buildings are fabulous. Very little energy is wasted. But that's because buildings are electricity users. And so if we look at electricity users, what happens is a vast majority of the energy is already wasted by the time you turn on the lamp. We spend all of this time focused on trying to replace lamps with something that's more efficient, whereas we could turn one off and it's better than replacing 20 of them with something more efficient. Just sort of this push toward compact fluorescence, which, I still sort of like really troubles me. The amount of sort of effort that's gone into having people install something that has mercury in it. But you think about this, yes, it's more efficient than an incandescent, there's no question about it. But if you start looking at the fact that if I want 10 energy units of light, of course, 185 units of input energy is so much better than 550, but that's a pretty horrible ratio. You think about 185 units, 10 to 1 amount of energy is wasted versus what actually produces light. And yet we get sort of fixated on working at the end of that whole pipeline rather than questioning what it is that we use. Primary energy for cooling has far outpaced primary energy for heating. Almost everything that we do presumes, almost all of our codes presume heating's a problem. Heating is not our problem. We think it's our problem. It is so not our problem. Everything in a building makes heat. If you need to actually make heat for your building, you're just not sort of living in your building properly. Everything in a building makes heat. When I lived in Boston, there was a gas main problem for 2 weeks, and I lost all of my heat in January. You just have to move your refrigerator around, and you have all the heat. But anyway, I'm not talking about people moving refrigerators, but anyway, almost all of our building strategies are about heating. And of course, this electrical equipment, which is driving up the electrical load, all of that is making heat. So that's also dramatically increasing the amount of cooling. Urban heat island also picks up local heat load, and something many people don't like for me to talk about is that when we start thinking about taking distributed energy generation at a building level, particularly things like photovoltaics on a building, we're really dramatically increasing the local heat load of that building. My other most favorite project is the Passive House project. I can't go a week without someone asking me if I've ever heard of it. And isn't this a wonderful thing? And I actually was in a sort of research meeting with some absolutely brilliant people who do micro systems research at Harvard. And this is all they could talk about, was that if only we built houses like the Passive House, if only we massively insulated things, if only we could, and of course you think about how this thing functions, and think about this from a body standpoint. In order to survive in the Passive House, you must have a fan running. If the fan doesn't run, if you lose electricity, if the fan doesn't operate, well, it's not you won't die, but it's not a healthy thing. That's a bizarre thing. A couple of years ago, I had one of those fellowships at Buffalo. They have bunches of them, like Michigan. And part of the deal, because they don't pay a whole lot, is every day spent in a different sort of great building in Buffalo. And I spent a day, in the Guarantee building. And the law firm that owns it, the owner of the law firm, heard some of my lectures, and while I was there, he said, I think I know what you're talking about, because we don't heat the building anymore. January, February, Buffalo, people think we should be heating it, but we haven't needed to heat it in a couple of years. And he goes, is it my dimming equipment? Is it all my lighting? Yeah, that's it. That's very much what it is. This is the type of stuff that's really going to be an issue in developing countries. The fact that cooling is our problem here. Cooling is a big problem where we're seeing the biggest demand growth. Just another quick little thing, I also have been going through it and reading what benchmarks and things like that, and you will find this in almost everything, that where I was shocked when I was reading the space cooling calculations for buildings, which for a house, this is a house, if you followed their guidelines today for what a house should be designed, you'd be designing an HVAC system that's even more rigorous than what we have for a medical lab. And I thought, why on earth would they recommend all of this extra equipment? And of course, that's what you get. That's where all of that came from. Again, sort of looking a little bit at urban heat island here, East Coast. This is Houston. I pick on photovoltaics a lot. You know, one of the things that I do think a lot about, though, is that we have an aging electrical infrastructure. And while thermodynamically this is not a good idea, it might be one of the few ways that we can upgrade our infrastructure. You know, you privatize and you distribute, and you know, with an incredibly deregulated system, that's that balance. And I think this is what we should deal with or think about as we're looking at almost all of these. I invited Group Rutland to speak at Yale a couple of years ago, and one of the things she talked about was that there was no solution. I mean, even though she's considered, you know, the empress of sustainability, but there really was no solution. It was simply a constant negotiation and renegotiation between bad alternatives, trying to find the, you know, always sort of move in a better direction, but the alternatives were always not great. And I think this is going to be one of them. But you start thinking about deregulation, trying to think about the building as an energy unit, 12,000 power plants, 3,500 utility companies. This is really different than it was, you know, 15 or 20 years ago. But this is an important map. There's only 3 grids in this country. Texas gets its own grid, and I'm not sure why. And of course, part of our grid is actually extended to Canada. And if you go over here and you start looking at where I live, in here, anything that's installed, from a photovoltaic in a building to a major power plant, gets balanced here or gets balanced there. It doesn't get balanced globally. It gets balanced at that level. And just to show the interconnection of all of these different things, this comes from Homeland Security, which is, you know, looking at when anything gets disrupted, how it affects other things. And again, you can't think about a building as having its energy coming in versus its energy coming out. Everything is connected. I think we should be concerned that Homeland Security does not know how to spell energy. But, you know, that's it's part of the software programs that we're developing in order to see what happens if any sort of even small power plant falls off the grid and how it affects other things. This is this map of exergy I mentioned. I'm almost through here. Map of exergy. You know, we think about electricity. We overthink about electricity. And what we're looking at here is sort of high quality energy and low quality energy. And if you were really sensitive about trying to use the least amount of energy, you start at the bottom and work up. You only use alternating current things that you have to use it for. But the thing about alternating current is it's like the universal donor in blood. You can use it for everything. And so it makes it easier for us to use it for everything. Each one of these things has sort of a more and more limited kind of path. But ideally, you'd be ground and working your way up and doing this type of what we call exergy matching. Matching the need that has to have something to the type of system that you have. There's a lot of interesting work going on now and that I'm just starting to get involved in microgrids with direct current. And of course, if you think about digital equipment, if you think about LEDs, they want to operate on direct current. So I think that's going to be an interesting area for us. One of the things that we don't take very good advantage of, you know, everything makes heat. And this is really problematic because a building always has to dump heat, no matter what the external conditions are. We don't have many natural cool sinks, but we do have some. And a lot of it simply has to do with beginning to look at infrared maps of areas, even determining where a building might face, where a window might face, where you might put a server in a building, where you might put your refrigerator in a building, instead of thinking again about the building as sort of being a self-contained unit, that you actually have a series or a map of these different cool sinks that you can take advantage of. Again, this is when you're thinking about cooling being the problem and not necessarily about heating. This is my one boundary layer image. A lot of my early work in research was in trying to manipulate this boundary layer. We spend all of our time making, air for this entire space when the body cares about something that's happening 1 centimeter away from us, that's it. Different boundary layers of different things. I show this, I should probably show this 100 times because I love it. This is a boundary layer, nice, tight, obvious boundary layer from a frozen pizza box, and dropping down. But these boundary layers are actually incredibly autonomous. Our HVAC systems do everything they can to disrupt it. If we begin to sort of understand how things discretely behave, we have huge potential there. I have a really large project right now where we're not going to be doing it for the bodies. I'm working on a project for 12 million artifacts. And we're actually going to be controlling different things. Like one of the first things we're going to do is the Egyptian collections at Yale. The collections come from everywhere, so there's bunches of mummies and papyrus and things like that, all have different thermal requirements. And so I'm building little microclimates that actually will travel with the artifacts. Do that before I can start working on people. So pulling this together, one of the ways to start thinking about all of this is that all of these things that we use energy for in building are only about us, only about the body. Lighting and heating, only about the body. So the need occurs at this level. We've got to think in terms of the fact that the impact, the actions we take occur basically at this level. And regardless of whether a building is a unit of energy, it's not, it's a unit of property. That's how we take action. So we have to think about the level which we take action. The impact occurs here, and of course the consequences are a much longer time frame and a much longer spatial scale all the way out there. So I'm going to end with 7 slides. Storefront for Art and Architecture in New York has a manifesto series that it puts on. And earlier this year in February, this was called Redux, and I'd say it was the strangest collection of people from, Mark Wigley to Chris Perry to me, where it has to stand on a soapbox and deliver 7 slides of the manifesto. So I'm just going to share with you quietly the manifesto that I delivered. Thank you. I'm happy to answer questions. I should say that, even though I started off by being somewhat critical of sustainability, my real interest is in finding ways to save energy by quarters of magnitude. I mean, this is really my intention, is to sort of radical reductions in energy. At the same time, I'm very interested in the pleasure of essential environment. So many of the things I think about saving energy radically, for instance, starting to, instead of these ubiquitous, monotonous
that one would, now that we have digital lighting, that we could actually choreograph light for the eye, I think is one of the most exciting areas that we have to deal with. But a radical reduction, if you think about it like that, not so interested in just replacing, incandescents with fluorescence and then LEDs with silver. All the way.
What kind of light bulbs do you use in your home?
I love my incandescents. I use those. However, if you would come to my office at Yale, I'm the only person who doesn't use lights at all, other than when it gets dark. But I use very little light. But I love the sort of the warmth and the color of an incandescent.
So at Yale, you teach design studios. I'm just wondering about your teaching, the lighting seminar, the kind of more scientific or technological aspects of your work. Do you get an opportunity then to take that into a design environment? And if you do, what are the kind of products?
Well, this is, we all have our sad situations in life, and I had really had hoped when I went to Yale, and certainly part of what he placed me down was that I would be able to teach studio, and that hasn't happened. Now that said, we have a particularly tight relationship between the classes that I teach studio, and we've now embedded pieces of this in every single one of the 4 studios, including, and that'll start happening next week. We have a two-week daylighting workshop that all of the second-year students will go through. So there's ways of bringing it in. I say I get my sort of pleasure out of doing a seminar that I teach on advances in light materials, and so here I get to have my fun. But I'm doing sabbatical next year at the Technical University of Munich, and in Congress, I was teaching studio. So I'm looking forward to seeing how that would work. Maybe I'm going to be terrible. So we'll see.
So when you're thinking about building, are you designing around energy sources, or are you doing your energy around your design?
Let me think. So,
Or is it like impossible to say the next point or to say
well, for me, I'm always thinking in terms, not necessarily in energy, but in thermodynamics. I'm always thinking about something moving. So that's generally a beginning. The beginning part is, well, it's actually simultaneous, but it's not building. It'll be sexual experience and thermodynamic behavior. And, I really think about the building as being sort of armature for that, but not the thing that I'm working on. On the other hand, nobody pays me to design buildings. So I do get paid a lot to consult. Oh, sorry.
What do you think, as practitioners, we can do in the short term? I mean, it sounds like the solutions that are being proposed are not really solutions. So how should architects respond now for clients that ask for sustainability?
Well, I really think it's going after those 3 areas. If there's any way to reconsider how one might do an interior or spatial layout to really minimize the condition space. And even if you're sort of in an opportunity where you can't, minimize the overall footprint, if there's some way to even start to minimize the part that's fully conditioned. There's many opportunities to do that, only the part that you have to control. I think along those lines, if you start thinking in terms of cooling being the problem, you start really reconsidering how you site. I don't believe that any of this should be formally deterministic, but nevertheless, there are certain relationships that one can milk on this and make a big difference. But the one thing that you could do immediately, and it would be for any kind of building, is really question the lighting designer. What should be the baseline level of lighting? how do you make the lighting actually more sort of like a richer experience for the eye? And it ain't going to be in sort of a big layout of things uniformly spaced.
So space is one of the big problems. How do you ethically keep the Chinese satisfied with 4 square meters per space?
They're not doing that anymore. They're way
But either way, like,
But,
that doesn't seem like a reversible desire on anybody's part. So how do you keep, media in China so significantly depressed in their spatial requirements?
that's when we have to start then decoupling what the thermal characteristics are from the building. So as long as we have homogeneous systems that are fully coupled and integrated with, the building volume, but if we could decouple, then I think that's a longer term type of thing. I will say that last year, and it was right before the Mexico talks, I had a lunch, a small lunch with the energy director of energy, whatever, for India. And the ambassador for India was there as well, and they made a pronouncement in preparation for the climate talks that they were not going to be made scapegoat. That they in China had a right to have the same kind of opportunities we do. That the rest of us are the ones that put them in this, put everyone in this. We were the ones that had to deal with it. But nevertheless, this is going to be a continuing crisis. So I think that the challenge really is for us to deal with this decoupling in any possible way that we can. So an opportunity to improve the living environment at the same time by improving the living environment and sort of strip away from the hugely energy intensive systems that we use. I don't have that answer yet. I really don't. I don't know if it's going to happen in a long time.
Would decoupling require architecture being less vocal about its primary responsibility in this area? In other words, to decouple the envelope. And what I was always looking at boundary layers to me was that really the environment is the problem of fashion designers, not architects. The idea is the building is so excessive that it's not really a control mechanism, but other systems, gizmo light or closed light, at another scale are the issue. So if we only imagine architecture as a solver, then we're spending good money on that, as you're saying.
Yeah, I that's my earlier work, and that's certainly where I began many years ago. And what people here probably don't know is that my early research actually was working with micro machines in order to manipulate where boundary layers were. And now I've gone to the point of, I think this is where concrete used to go. So it really shifted in that. And part of it is in sort of like going from, dealing with achievable things as opposed to things that may not be as achievable immediately. But, I've never had a good answer for that question. Certainly when I was working on these, so that's why I worked on microenvironments for mummies as opposed to microenvironments for human beings. Is, beginning to think if I can even sort of develop these things that will be moving throughout the space and sort of always bring their microenvironment with it. I don't know what those implications are for people, but probably not fashion.
I was just curious what your thoughts were on, I think it was 2007 legislation, the energy and security independence act. And it was a big piece of legislation that has a bunch of people running to the grocery store to pick up halogen light bulbs. But, if there's any aspect of that, light bulbs that, might not find effective, that you might be doing. We can use light bulbs as an example. What are your thoughts on that?
Well, the light bulb is oddly something that I've been kind of like embroiled in a big controversy because I also have been working with the two art museums at Yale, and all the lighting systems that were installed have become obsolete, and so they're looking at having to attention, research money, policy, going after the wrong thing. And I just think about all of the manpower, and all of the money, and what we could do with that in terms of rethinking, as opposed to sort of continuing to focus on, and almost all the solutions they have for the incandescent are environmentally way more problematic. They might use less energy, but they have a much greater impact on the environment. Yes.
And yeah, I have a very fundamental question. Sustainability is an invention of the 90s. Would you as an expert on that also address it? Would you ever think it will ever lead our discourse of architecture again, or will it always be part of it from now on?
I think as I've gotten older, I've sort of learned that whatever I think is going to be so never is at some point. And I would have said a year ago that it wasn't going to be. That's why I've been sort of so taken aback by all of the stuff that I've been seeing, hearing, and reading. And the part that makes me concerned is that, I'm not that old. I was a child doing the first passive solar stuff. But, we had a whole generation of architects that sort of really resisted moving towards sustainability based on the bad experience that so many people had in the 60s with this. I hate thinking that this would actually be an even bigger backlash that's going to affect an entire, another generation of designers and keep them away from sustainability. They get caught up in the complaints, they get caught up in sort of or the frustration with the failures, they get caught up in litigation, that groundswell. And so I'm starting to hear it, more and more. So I don't think I'm actually really good at predicting the future. So I know, a year ago, I didn't really
some local dynamic and manipulation of space, like around the body, that you sort of end up with, which you favour. How do you differentiate that from the fully conditioned space of like passive house?
Well, if you start to look at the different sort of regulation mechanisms of the human body, we can deal with a huge variation in temperature as long as it doesn't get too hot. But we can take it pretty cold. So we can probably have about a 40-degree swing in temperature in this space and have absolutely no problem from a thermoregulation standpoint. So what happens is that, how much your body needs in order for health is very different than what we might think about as comfort. I do find it somewhat bizarre that thermal comfort to us is neutrality. We'd be horrified if we thought acoustic conditions or light conditions should be completely, blank and neutral. Somehow we demand that our thermal environment on the interior is completely neutral. And that's one of the reasons I think so many of us find such great pleasure to go outside, even if outside is more humid or colder or warmer, simply for that variation. But that said, most of the thermal receptors in the body, the vast majority of them actually are out of the periphery. And so they're responding to rate of change. So do you manipulate just that rate of change? I've seen a couple of really interesting projects that I would be very interested myself in getting involved in that deals with much greater variation in environmental temperature, but then just sort of finds a way to act locally around the hands. Of course, that means you're sitting in a cubicle, so I don't like that idea. But, how does one begin to sort of just act where you need to act? It might be as well as just simply some small vertical gradient panels. We've overprivileged things that are horizontal, but a vertical gradient panel in terms of exposure might be all that one might need in order to control the rate of change right here without sort of tethering you to a space. But that's, to me, the part of the decoupling, you're letting that environmental temperature float instead of trying to massively control it. I said, going to do it with the mummy first, and then see how that works out.
Do you think retrofitting